My name is Sofia Magalhaes, and I'm from Austin, New York, in the United States of America. So, what my project looked into is a pattern called selective vulnerability to Alzheimer's disease. And essentially, what this pattern details is that certain areas of the brain are impacted much earlier and faster in the disease than others, which may remain largely unaffected until the disease becomes significantly severe. So while we are sure this pattern occurs, we're not entirely sure why, which is where my research comes in. So I examined a possible cause of this pattern specifically by looking at the astrocytic maintenance of blood-brain barrier integrity through their ensheathment of blood vessels with their processes. Now, I examined this by analyzing images of brain tissue, human brain tissue sourced from the prefrontal cortex, which is an area more vulnerable to Alzheimer's disease, and the primary visual cortex, which is an area more resistant to Alzheimer's disease. And these tissues were stained with ALDH101 and GFAP, both astrocytic markers, and collagen 4, which is a blood vessel marker. So by analyzing these images, I actually found that in the visual cortex on a regional level, this astrocytic coverage of blood vessels remains relatively stable as AD increased in severity, while in neuronal layer 4 of the primary visual cortex, this astrocytic coverage actually significantly increased as AD increased in severity, specifically when GFAP, that reactive marker, was expressed. So what this indicates as layer 4 has been known to be an area of vulnerability in the primary visual cortex is that in response to that increased AD severity, these astrocytes are actually adopting more neuroprotective functions by increasing their coverage of blood vessels to provide more support to their environment. And this indicates that region-specific characteristics and reactions of astrocytes may actually play a key role in rates of vulnerability and specifically resilience to Alzheimer's.